Hello, everybody. My name is Elisa Baum, and I am Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of house cleaning. If you would, please raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you can hear me. Okay, I see some hands. Great. Thank you very, very much. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, enter them in the questions field within the control panel. And at the end of the webinar, we will take as much time as possible to answer your questions. And if we don't get to your question, don't worry. Peter will post a follow-up blog and answer those questions that we did not have a chance to address. And those will be on Percona's MySQL Performance blog. In addition, a recording of this webinar will be made available to everybody within 48 hours. So with that said, I'd like to thank you for attending today's webinar called MySQL 5.6 Configuration Optimization, presented by Percona's CEO and founder, Peter Zaitsev. And with that said, I'd like to turn the floor over to Peter. You have the floor, Peter.
Hey, Lisa, thank you. Thank you. Well, you're about to witness one of the most boring presentation of your lifetime, because we're about to go through so many different MySQL options in it. So what we're going to do in this presentation is to cover MySQL configuration basics, basic approaches to doing MySQL configuration, cover what's new in regards to configuration MySQL 5.6, and then the largest amount of time we'll look at the most important options, and lots of them even if you'll be very selective. So what is the most important things to know about the MySQL configuration? First is what the default configuration is quite poor. You don't want to be running MySQL in default configuration. This is mainly because that configuration designed for MySQL to be able to run on even quite small servers, and the MySQL does not scale its configuration with server-side as some other databases do. You may have heard that in MySQL 5.6 certain defaults have been changed, but they are still not as good as we would like to run the server on the high-powered server. Second important thing is I would really recommend you understand what you are changing. There is a lot of advice there on Google which you can which can be helpful 95% of the time, but in other cases it can give you something from bad performance to actually causing the data loss. Right? So be careful with that, and I would suggest if you find some good configuration settings, somebody claims, oh my gosh, I've improved my performance so much, go check the MySQL manual what those settings mean. Right? For example, one of the common blogs I've seen would write about disable Innodb double write buffer to get a good performance. This is wonderful settings to use for benchmarks, but that's not what you will use in production because you can get corrupted database in case of crash if you set this option, which you probably don't want to have. Another important thing is to really avoid what I call an obsessive viewing disorder, right? By trying to change every setting available out there, finding the best fit for your configuration. Most commonly, setting somewhere between 10, maybe 20 MySQL settings will give you 95% of the possible peak performance you can reach. And you will be much more safe this way because the rarely used settings set way outside of their common values are typically not tested very well by a large number of people, and because of that, they're more risky. Other important thing to consider is what most important options, what most MySQL options, they don't really scale. Going to serve with a lot more memory, CPUs, hard drives, you can't just take away and scale in proportion. For example, changing sort buffer size from 8 megabytes to 32 megabytes, going from 16 gigs to 128 gigs would likely be disaster for your performance. Another common mistake I see is misunderstanding the scope of a unit of the settings. For example, many people, especially coming from other databases, would think, oh, sort buffer size. That is probably some global sort space which MySQL manages for all transactions to be used together. Wrong. That's what MySQL does. And MySQL sort buffer size is set per connection, right? For every connection which needs to do a sort. Table cache size is another example. You may know what number of settings, number of caches in MySQL, query cache size, key cache, Innodb buffer pool size are set by specifying amount of memory they use. But the table cache is different. It specifies the number of elements it would have. And MySQL is not smart enough really to give you an error in this case. If it sees this m suffix, that simply means what it should multiply the value before it by something like 1 million, and it will just set your cache to 64 million in this case, which is probably not what you are looking to do. It is very also important to know you can set a lot of variables locally for the current session, which is very valuable because for a lot of variables you will get better performance if you are set to low values for small queries, but some of your very complicated queries which needs to do a lot of join, sorts, may benefit from setting those values higher. Setting variables per session allows you to exactly get both good performance with small queries and with large queries. Basic mistakes. There are a few basic mistakes which we noticed people having with MySQL configuration, which can then get them confused why options are not being changed, picked up properly, and so on and so forth. The most common one is confusing which MyCNF file should be used. Depending on wherever you are using Debian-based or Red Hat-based distribution, you will have a different MyCNF file used by your MySQL server, right? And you want to pick the right one because that one simply is not being read at home. The second common mistake is duplicating options. For most options in MySQL, the second option will override the previously set one with no warnings, right? So if you have a multiple options set in the MyCNF, the second one will prevail with any warnings. And this also has to be combined with another issue you may have. Through the years, for many variables, there have been multiple synonyms created. For example, table cache is the same as table open cache, but it's not the same as table definition cache. And this is something which, well, you just have to know. And if you use a synonyms for the same variable, it will be seen exactly as you are duplicating the options. Finally, I would mention using the wrong section for options. The MySQL server does not read the whole MyCNF file, right? Or it actually reads the whole file, but only takes the options for one specific section. If you are putting the sections outside, putting variables outside of any section in MyCNF file, or putting in the wrong section, then server wouldn't pick it up. There are other less common cases, like MyCNF being unreadable because of permissions, or SE Linux or AppArmor configuration, and some others. So the best idea is, especially if you're just starting to tune your MySQL server, make sure what the changes you have done actually pick up when the server was restarted. Now, some of the good practices for managing configuration. I think the very important is to keep the configuration files in sync on different servers as much as possible. I have seen many people which try to overly optimize configuration files and keep them very different on very similar services, which often cause a lot of very hard troubleshooting problems or other confusion. My suggestions would be to establish some MyCNF configuration you use for database servers in your application, right, or at least for a specific role in your application, and keep it in sync. Even if you have a little bit different MySQL boxes, let's say the amount of memory is different, then you may want to change one or two variables in relationship to that. But don't try to change too many variables. It's not. It can be cause of the mistakes. I also would highly suggest to keep a record of changes. I believe the best practice at this point is to manage your MySQL deployment with some tools like Puppet, Chef, Ansible, wherever you choose, especially on the large scale. And those tools often integrate very well with the config, with making sure configuration files are under some version control system. So you will always know why you changed them and be able to go back if the changes have some unforeseen effects. If you're not doing that, if you're not there yet, at least keep some form of changes in your MySQL file. For example, saying, hey, raised Innodb buffer pool from 4 gigabytes to 8 gigabytes based on advice found in the manual on this URL, right? That will give you an idea why you changed something from what value and when, and you can troubleshoot things appropriately. The most common mistake what we see with general configuration mistake we see is allocating too much memory to MySQL, and then MySQL start to swap. This is a very bad. You never want your database to be page and swapping actively. And it is much better to set a little bit to have a little bit of memory free, right, and not use all memory than to overcommit and have system swapping. What is important here for monitor swapping is what you want to look at their swapping activity. For example, see and saw columns in Vim study if that's what you're using. Don't just look at the amount of swap space allocated, because it is fine to have certain small amount of space allocated in swap, because typically there are certain processes, certain parts of the data which are not really needed to their server operation, and they would be swapped out to allocate memory for what you really need the most. But you don't want any swapping activity after server has settled down. Okay, so let's talk about MySQL 5.6 and what's new in MySQL 5.6 when it comes to configuration options. First, MySQL 5.6 has significant changes to default. I think that is the largest change since, I don't know, since the last 10 years or so. Some variables have changed defaults, and other variables are also now computed based on other most commonly set variables. Few things which I thought was worth to mention. Innodb file per table is now default, which is a very good configuration for most of use cases, unless you are having a very large number of tables. We have a buffer pool instances now 8 by default, which will make MySQL more scalable out of the box for large amount of cores. We have Innodb log file size at 48 megs, well, which is better than 5 megs, which it was default, but that is still very low log file size for any high volume workloads. We have Innodb all block size, which have been changed to 100, and this is kind of variable with complex meaning, but the outcomes of this variable to this value means your buffer pool becomes scan resistant, which I think is very valuable for maintaining the high performance, even if you do some MySQL dump-based backups or something like that. Innodb starts on metadata off by default. The outcome of that means now, with the default configuration, your information schema queries will be faster, sometimes as much as 100 times faster, so that is a very good change. And the thread cache size, which was disabled by the default before, now is set to a certain value and managed automatically based on max connections value, which is a very good thing, especially if you are having a lot of connections per second. The MySQL 5.6 was generally very much optimized for being able to accept many connections a second, and I think guys at Facebook report they are able to get 25 or 35,000 of connections a second, connects and disconnects in this version, so it's quite good. Max load packet was also raised from 1 megabytes to 4 megabytes, and what that gives us is MySQL in default configuration is able to accept much larger queries than it was before, which is relevant for large blobs, large insert statements, stuff like that. Okay, the next, very small but wonderful change. Before MySQL 5.5, we had 5.6. We had a lot of users would run into trouble trying to resize in a log file size. Because if you just go to MySQL file, change that option, MySQL server wouldn't start anymore. Now, thankfully, their configuration is automatic. If MySQL detects a larger log file size, it will simply create the new log files and continue running as normal, just as we would probably expect. Another big change in MySQL 5.6 is much improved performance schema. And performance schema is kind of a little bit tricky when it comes to configuration. You have to configure that both through configuration file and tables. There is very few information I'm going to give in this webinar because I have given an extensive webinar on performance schema configuration and usage in MySQL 5.6, and you can find both slides and report for that available on the URL below. So what do you need to know about performance schema for 5.6 in a very few words? Well, first of all, performance schema comes at cost. Their cost may be somewhere from 5% to as much as 20 or 30%. So either you want to use performance schema, or if you are not using that, you can use skip performance schema to get the best performance, possible. There are also a number of limits which have to be set statically for performance schema. Number of stages, number of utixes which are able to be tracked, and so on and so forth, right? Which you also may want to change in MySQL file. What is also new in MySQL 5.6 is what you can configure the instruments directly in MySQL file instead of have to manually modify their tables to enable them. And in this case, I give an example how you can enable counting weights for all condition variables. Another interesting thing which comes to MySQL 5.6, certain variables now have some new or different meaning. The most important thing, I think, is a join buffer size. Before MySQL 5.6, I wouldn't pay a lot of attention to this variable because it will essentially only be used for Cartesian products join, which we know we want to avoid, right? We always want joins to be well indexed. Well, in MySQL 5.6, now join buffer size also used for BKA, batch key access, right? And as you can see from this graph, there could be very significant performance difference for certain complicated queries depending on the join buffer size. So keep that in mind, but as I mentioned, this is one of the variables you want to set per thread for those very complicated queries. Don't just default to very high value because some of the smaller join queries may suffer. Top options, which I would suggest to consider moving to MySQL for 5.6. I/O capacity and I/O capacity max. The default for I/O capacity is 200, which is probably way too low for a lot of modern storage. You want to increase that. Innodb LRU scan depth, which is a new variable which defines how page replacement or how cleaning of the pages in an LRU is going to work. And it can cause a serious impact for write-incentive workloads. Sometimes you want to change that. I'm not going to go a lot of replication options in this presentation because MySQL 5.6 has so many replication options. What you really want to give it a special look. But Two settings I mentioned is relay log info repository and master log info repository, which you can set to table. This gives you a lot more robust and crash-safe replication by avoiding storing the information in the files and storing them in tables and cans instead. If you have a highly concurrent workload, you want to increase stable cache instances amount to be higher than default one. We spoke about this joint buffer size, and Innodb checksum algorithm, which is also can be very valuable, especially if you are using fast storage like SSDs. You want to go to the new checksum algorithm of CRC32. The trick here, though, is the most beneficial way to set it is when you recreate the database from scratch, right? Because that applies to their database structure. For SSDs and also for number of conventional hard drives, setting Innodb flash enablers to 0. That may also improve performance for write-intensive workloads. And finally, I wanted to mention this new feature in MySQL 5.6 called Innodb Monitor, which gives you a lot more Innodb information which is available in show status. If you're using that information, you can enable a monitor, and it gives very low overhead. If you're not using that information, then obviously there's no point. Okay, let's go now to the last section of our webinar and talk about some of the most important options in the MySQL 5.6. And I split them in a few different classes. Before we go to the options, I wanted to cover briefly is as we set the options, often we would refer to show global status value, right? And often to look at those values, we will be interested both in the values from the start and as well as the current rate of change per second. One way to get a very good output for all of those together would be to use ptmax tool from Percona toolkit, which allows us to see like vmstat-like format, right, for all those options, showing us WOP information since uptime as well as for the increments, right, which are 100 seconds in this case. I find that very convenient to see both of them at the same time in the text mode. Okay. Now, looking at the general options. The most important one to set is max connections. How many connections do we want to allow? And it is especially important in MySQL 5.6 because many other variables are going to be computed for you automatically based on the max connections. How do you know what max connections values is good enough for you? Well, you can watch max used connections in status variable, and it will tell you the maximum number of connections which was ever used. Now, a typical mistake I see here is people see, oh, I have been very close, or I have reached my max used connections. Let me beef up max connections. Well, this is not the only solution we have to explore. You also should check whether your application configuration is correct. In some cases, reducing amount, for example, of connections in connection pool or something of this sort is a better way to resolve the problem of running out of connections. Thread cache. This is a cache of threads which are created, which helps us to prevent excessive thread creation on the connection and it's also after set for you in MySQL 5.6. Otherwise, if you want to set it so manually, I find values between 50 and 100 as a pretty good value, and I typically would watch number of threads created to see how many threads had to be created, which essentially are cache misses, and make sure there are no more than a few threads a second. Table cache, which is their size of their, which is also known as table open cache, and this is the cache for open table instances. And the instance keyword is important here because if you are running multiple queries concurrently accessing the same table, or even if you have a self-join accessing the same table multiple times in the same query, they will require multiple table instances, right? So single table may have a multiple instances in that table cache. For that, I would typically start somewhere between 4,000, maybe 10,000 of table cache size, and watch open table status variable to see how much tables were used. Now, what is important to note here is this is a cache which MySQL only allocates as needed. So it's relatively safe to set that to higher values than you would need. You could also find some older articles about having a negative scalability with the table cache. This is indeed the case which would apply to MySum storage engine, but Innodb works pretty well with the large table cache sizes. Another variable you want to consider is a table cache opens cache instances, right, which we already spoke about. Another variable to consider is open files limit, which again is set automatically in MySQL 5.6, and which is responsible for how many open files on the operating system will MySQL try to allow. I try to set it high number because this is just the upper limit, and I see no point in not allowing MySQL to use as many file descriptors as you want. On the modern operation systems, this is very cheap data structure, which typically is not a problem. Table definition cache, which is a variable which looks very similar to table open cache, but unlike former, it caches table definitions, which is essentially you can see about as output of create table. In this case, you'll have only one entry per table, right? So for those, you can also watch the related variable open table definitions and make sure it's not increases. And what I do typically is set this variable to number of tables plus maybe 10%, just to make sure I can always feed all my tables in table definition cache and forget about that. Of course, that applies to moderate and small amount of tables. If you have 10 million of tables on MySQL instance, well, you may want to control this variable. Another variable you might want to keep an eye on is metadata log hash instances. This is a variable which also have to do with a similar kind of table definitions, locking table metadata. It can cause contentions, and it may need to be set to a higher value, but it also only helps if you have a large amount of tables. If you just have all your contention focused on a single table, setting that variable wouldn't help you a lot. Backlog. This is a variable which may need to be adjusted if you have many connections per second. MySQL 5.6 sets that to value which is default, which is based on max connections, but it may not go high enough if you have a very high rate of connections a second. I find something like 2,000 is a good value for high number of connections per second, or spiky number of connections per second. Note, if you set this value to relatively high values, you may want to check what operation system allows you, because what backlog sets is the listen queue, which may be limited per your operating system configuration. Max allowed packet is a variable which limits maximum size of query what MySQL can take, which is important for your inserts, maybe multi-value insert and handling logs. But it also limits the internal length of a string which MySQL is able to accept. I would say default value is good. If you're setting to you're having some larger queries, maybe 60 megabytes, 64 megabytes are reasonable value. Don't set that to 4 gigabytes as some people say, because that will make your system less secure. in terms of developer mistakes, right, or some malicious users, because every single connection will be able to allocate as much memory as this variable, right? And so with few gigabytes size, you can really let users to get database server out of memory quickly. Max connect errors. This variable, which is either very important for you or not. It was default for this variable was also raised a little bit in MySQL 5.6, so it is maybe less of a need to change that. When is this variable important, or what could be the reason for you to set this variable? Well, in some cases, when you run MySQL in not very reliable networks, you may have certain connections failure due to network errors, timeouts, and so on and so forth. MySQL would count number of such an error, and after a certain amount, it will block the host from connecting. What that may mean is if you run in the cloud and have some issues with network which were outside of your control, you may get alerted at 4 o'clock in the morning because now your web hosts are unable to connect to your database host, getting this funky error message. Especially if you are running on the isolated network and there are no some remote users trying to from outside of your organization trying to connect to MySQL server, then typically you don't need this kind of protection, and that's safe to set it to some high value. Skip name resolve. Another option to increase robustness of your system. If you enable this option, you will avoid the DNS lookup, both forward DNS and reverse DNS on connection, which is both faster and safer, making you less dependent on your DNS infrastructure. Right? So that's why I would recommend that. If you set these options, then you cannot use hostname in your grant statements anymore. That's essentially their only downside. The option which you should not have enabled in your configuration is old passwords. The old passwords applies to MySQL 4.0 and below password hashing, which is very old for now, and which will cause very insecure password hash use. That hash can be used in a break-in in the matter of seconds, and there are a number of programs for those which you can find in the internet. So make sure you're not using old hashes for passwords. Some of the general options. Log bin. And binary log is something you should keep enabled, right, for any production MySQL use. Even if you're not using replication, you want to be have it enabled because for point-in-time recovery purposes, right? If you want to take a backup and then you want to do point-in-time recovery, you need binary logs to do that. I typically set that to something like MySQL bin or other fixed name to avoid default naming, which includes host name and which can be their issue. I've seen so many cases when host name will be changed by system administrators, right, without keeping MySQL in account, which will cause some issues with replication or other scripts. Sync bin log is a very good option to keep your binary log in sync with the transactions space, right? So if you enable this option, when transactions are committed, they will persist both in Innodb as well in your binary log. Otherwise, your binary log is just buffered file, and if you ever to lose the power, you may lose some of the committed transactions from binary log, making potentially breaking your backups or having your slaves be inconsistency. At the same time, enabling this option can be a very bad for your performance, especially if you have a slow drive. But generally, you can use this settings quite fine if you are using a flash storage or battery backup unit. In MySQL 5.6, another interesting option added, which is called sync relay log, which can help us on the slaves to keep relay log secure. which is frankly less important because relay logs are always can be refaced from the master, right, if something happens to them. Another variable what you want to know about is expiry log days. I suggest to set both log bin and expire log days for all production MySQL installs because you want to have your binary log enabled for number of purposes, but at the same time you don't want to have the space usage by MySQL being unbound. Expire log days allow us to delete binary logs after a certain amount of days. How many days to choose? Well, it depends. What I would suggest is to think about this variable, integrating it with the backups you have, and make sure you have at least 2 full backups you can recover from using your binary log file for backup safety standpoint. The next variable to talk about is TMP table size and max heap table size. Typically, those variables are set to the same value and used to constrain how large internal temporary table will be created in memory. If MySQL needs more space to run a complicated query, it will create the MySum table on disk instead, right, which will be lower performance. Now, what I see a lot of people is trying to tune this variable, setting it to very high values, and they still see number of disk tables, number of tables are created on disk. The reason may be what's being not enough memory is not the only reason. Another reason is your global text fields, and any selected global text fields which cause even for very small queries will cause the table to be created on disk, because memory tables don't support global text fields. Another variable to think about is query cache size, right? You may find a lot of advice about enabling query cache by default because it just provides us magical performance boost. Well, I would suggest to really test it in your application wherever that is really the case, because indeed, it can provide good performance advantages, especially if you have some complicated repeated queries, but it is also a huge cause of contention, because this is a piece of MySQL code base which wasn't optimized for multi-cores at all since it was created. It can also cause the stops for a significant period of time and as a caching validation process going. So be very careful with that. If you found it makes sense for your application to use it because, well, you have a lot of repeated queries and you don't use memcache or any other external cache, you can set it to some value, but don't set it to gigabytes. I would say somewhere between 256 or 512 megabytes is the maximally feasible practical value for this variable. Sort buffer size. Well, as I already mentioned, this is a tricky variable because the small value, maybe 6 and 32K, are efficient for small queries which need only to sort a few rows. But if you have a very large queries, you may want to set which scan and sort a lot of rows. You may want to set that to tens of megabytes, right? When you do set that per session. To see how many queries are impacted by this variable having a sorts done on disk, you want to look at the sort merge passes variable, which shows us whenever query is required to sort to be done on disk. Join buffer size, we spoke about this variable already. There is not much I want to add. Default storage engine. Default storage engine is in MySQL 5.6, same as in MySQL 5.5, is Innodb, right? So that means what some of your old applications may not work correctly expecting because they expect MySum storage engine to be to work. This is less so now than Innodb storage engine support full text search and indexes, but that still could be the case, and in this case you may want to change that. The interesting change in MySQL 5.6 is that there is also default TMP storage engine, right? So there is a different variable how you can set storage engine to use for temporary tables. And for a number of workloads, it makes sense to keep default storage engine of Innodb, but have TMP storage engine of MySum, which is a storage engine which will be used for explicit temporary tables. Implicit temporary tables which are created to resolve the queries are always MySum. Read R&D buffer size is our buffer which is used for sorts, reading rows in sort order from like forever in MySQL. But in MySQL 5.6, it's also used for multi-range read support, right? So there may be a little bit more wisdom to setting those values, right? So, and that essentially applies to using a very high values for this buffer, which may not work so well with MRR. I would also urge you to not to mix it with read buffer size, which is a MySum only variable, even though it doesn't really have that in the name. We spoke about temporary tables, and what in some cases we'll always get temporary tables created on this. There are also other sort temporary space needs MySQL has, such as creating temporary sort files. And in some cases, you may see the bottleneck by placing those in unconventional file system, because MySQL will be spending way too much time by flushing the data to a disk which is only going to discard very soon. The solution for this stuff could be using TMP files as a file system, which is pretty good using memory or potentially swap space if your temporary space needs are not very high. Or the other solution is configuring your file system in a way their flushing for this temporary data doesn't need to happen, or it can be delayed for long enough. MySQL will just discard those tables because query execution is complete. Another worry that you may have is what Innodb may refuse to use asynchronous, native asynchronous I/O when this option is set up on some operating system. And if that happens, you want Innodb to use asynchronous I/O, and I would just suggest you to put your TMP on another file system. Now, when it comes to optimizer, a lot of optimizer-specific options are moved to a single option called optimizer switch. So you can actually set it on per session basics with only single set commands. The default optimizer switch corresponds to what considers to be their best settings known to a MySQL team, but it may not be what works best for you or your query, so you may need to adjust that as needed in some rare cases. MySum settings. Well, I had actually a lot more data about MySum in this older version of this presentation, but I now removed those because there are less and less people using MySum, and I think with MySQL 5.6, with full text search moved to MySum, there are very reasons remain to use MySum explicitly. Even if you don't use that, there is still a lot of MySum which can be used for implicitly for those temporary tables. And because of that, you may want to set key buffer size to a certain reasonable value, maybe 32 meg or something like that. Some of those temporary tables may have indexes created on them, right, and may use the key buffer size. You also have tables in MySQL database, which are MySum in MySQL 5.6 still, and there is a very low chance, but there is a chance of maybe become corrupted if you have MySQL crash just when you've been granting permissions or just when you've been creating storage procedure. If that happens, it's good to have a MySum recovery enabled to automatically repair your corrupted MySum tables for stability. Now let's talk briefly about Innodb settings. Innodb buffer pool size. This is what you essentially buy your memory for. You want that to be set for 80% of memory, or so, sometimes more, sometimes less, depending on what else you may need to use memory in the system. Buffer pool instances avoid contention. Innodb log buffer size, buffer for log files, values from 4 megabytes to 128 megs make sense. Typically, important to note is it's not just the amount of writes which help us to decide on this variable, but also for heavily concurrent workloads, high values help us to reduce contention. Innodb change buffer max size, conserve insert buffer. The default is 1/4 of a buffer pool size, which is pretty good. If you're using solid-state drives, though, you may want to change that to be lower because there is not as much benefit from change buffer for solid state. Few I/O options for Innodb. The most important one, perhaps, is Innodb flash log at TRX commit, which controls the durability for us, right? What do you want Innodb to do when transaction is committed, right? One is default one and not truly durable one. MySQL would flash the log to operation system and call fsync to ensure it's persisted on the storage. Value 2 means it will flash, but it wouldn't call fsync, and that means it will persist in OS memory, but not on the storage. And if MySQL server were to crash, your transaction will be secure, but if the whole operation system crashes or power goes down, some of the last transactions may be lost. And 0, well, it's neither. The log file will be just flashed periodically, and last transactions which haven't been committed may be lost. Now, what is important to note here is with any of those settings, you're not risking to have corrupted database. Database won't be corrupted. The thing that you're risking for is losing some of the committed transactions which will not be recovered if the database is ready to crash. Innodb flash method is one of the most important things to control Innodb I/O. We suggest ODirect for most cases, which is unbuffered I/O, so Innodb bypasses OS buffer cache. In some cases, though, having a default provides a better performance for certain workloads. The next two variables, buffer pool dump and shutdown and now, allows us to save and then later restore buffer pool for fast warm-up. That is a new feature in MySQL 5.6. Well, the similar feature existed for a while in Percona server, which is kind of very helpful to minimize warm-up time after MySQL restart or crash. Innodb I/O capacity, we spoke about that, right? And again, default is assuming this can do 200 IOPS, which is a low value. If you have a RAID, if you have a solid-state drive or a RIFM, well, increase it higher. And in Innodb for MySQL 5.6, you also can have a burst capacity for up to which number MySQL 5.6 can go, but that's really needed. Read IO threads and write IO threads. Typically, we don't need to change those in MySQL 5.6 because they only service IO completion. So unless you are disabling native asynchronous IO, I wouldn't suggest doing anything about that. The new thing in MySQL 5.6 is ability for us to keep undo table spaces in a separate and undo logs in a separate table spaces, which can be quite valuable because we can put them on a different storage or something else, right? The three variables which control that is undo directory, which is essentially specifies paths where they are stored, undo table spaces, which allows us to specify one or several dedicated table spaces. They will be stored, and the undo logs is number of logs we have, which can be higher than number of table spaces, and higher numbers are typically created if you have a lot of contentions and an undo space, which will be allocated to those undo table spaces in round robin fashion. Other things, Innodb log file size of a redo log file. Well, the rule here is simple. Larger logs means better performance, but longer recovery time. So I would suggest you test how long your recovery time takes with different log file size and pick where log file size which works for you. Innodb log file size, I typically leave at 2, which is default, and Innodb file per table, we spoke about that. It's already enabled in MySQL 5.6, so don't disable that unless you have some very special requirements like millions of tables. Innodb data file path allows us to specify their configuration for Innodb system table space, which always exists, even if you use Innodb file per table. What I suggest here is to make sure you specify max size for that, so don't allow it to run away for whatever reason. Because if it does, well, you can shrink it. Innodb log wait time helps us to identify how long to wait for logs before bailing out. This is really something what you would set based on the application server needs, application needs. In most cases, default 50 seconds is fine. Sometimes you have very interactive applications and you want to say, hey, if I have to wait, and then it's better to give an error than make user wait. In other cases, let's say some bad jokes, we may want to increase that variable so we wait essentially forever for logs to be released so the bad jobs don't have to abort. In Innodb old logs time, well, we discussed this variable again, never good change in MySQL 5.6. In the div file format, I get a lot of questions about this, which essentially specifies what is the default format for the Innodb storage engine. I would say in MySQL 5.6 you want to set that to Barracuda, which is a new format which allows you to use compression as well as have other improvements. This is where all improvements are focused on those days, while it also has been out for quite a while, so it's safe to use. Innodb starts with the metadata. We spoke about that. Another small variable is to keep in mind for very high contentious workload is Innodb sync size. If you have a lot of mutexes and other structures on Innodb, increasing sync from a default value may be valuable. Few visibility options. Even though MySQL 5.6 has a performance schema, for many workloads, plain old software low-query log can be very, very helpful to analyze your workload for developers and so on and so forth. Log slow queries would enable such the slow query log, and long query time can allow to set the long query time, set the threshold for logging, right? What we typically do is set that to 0 when we want to temporarily enable login, get a sample of queries, and maybe then set it back. If you use a Percona server, there are many more variables which control what you can do with the log files. But the most important of them is log flow verbosity, which you can set equals to full and get a lot more data about query execution stored in your format, in your log file. Couple of other options, log warnings. This helps us to get a lot more warnings like unexpected disconnects and other minor issues in the error logs. Some people like it because it provides information about troubleshooting. Others don't because they prefer error log to contain only error information. I leave that up to you. Another variable I would consider is user stats, which is a feature which is available in Percona server and MariaDB, which allows us to gather index usage statistics and table usage statistics at very low overhead, which can be very helpful to understand where your load comes from, wherever indexes you have are used or not, and anyway. Okay, so we are almost done with our marathon. A lot of options I have covered, but there are really a lot more options. There are more than 400 variables available in the latest MySQL version, right? So, yeah, but at the same time, don't feel intimidated, because for majority of workloads, you may need to just set a few of them. Now, if you are wondering how you can get started with configuration files and don't want to start from a clean page, I would suggest you go to tools.percona.com, and we have created a tool which can get you going with basic settings, size it for you based on the size of your hardware, which one you can custom tailor for your workloads. Now, a few links for those who would like to learn more about MySQL. We have a few webinars coming out. Next, there is a link which lists those. The next two ones would be Running MySQL and Hadoop for big data, and also Running MySQL on Linux, which I will deliver myself on October 9th. We also have a training program which goes in a lot more in-depth discussions of various topics of MySQL, and which can get you up to speed very quickly. We both have private and public training, as well as virtual training if you guys prefer not to travel and kind of just learn online. And then the last one is Percona Live in London. We are running a conference in the London, which has a tons of very good sessions, tutorials, and keynote. And I would, if you live in Europe specifically, or United Kingdom, I would suggest you to check it out. Thank you.
Thank you very much, Peter. We have a ton of questions and very little time left. So what I can do is take just a couple, and then anyone that we don't get to, don't feel bad. Peter will do a follow-up blog post on www.mysqlperformanceblog.com, so we'll get to your question that way. So with that said, Peter, I'll go ahead and read you a couple, and we'll take it from there.
Thank you. That sounds good.
Sure. Is there a tool to run against an older version of a database, such as 5.1, that lets you know if your schema structure and data is compatible to upgrade?
Yes. Well, schema. So yes. Well, this is not really the configuration topic, but it is a very important topic these days anyway. So I'll answer that. So when it comes to upgrade, what we do in terms of schema is we would use MySQL dump with -d option to essentially dump a schema with no data and then load it back into MySQL to see if there is any errors happen. Right. Typically, we don't see any issues with upgrading the schema, because there are very little schema-related features which are removed in new MySQL versions. Now, where you may have more trouble is with queries, right? Some queries may get a different execution plans or be slow for other reasons, or maybe even produce different result set because some bugs are fixed, right, or added. For those, we have a PT upgrade tool, which is a part of the Percona toolkit, and if you're upgrading, I will definitely suggest to check that out.
Okay, and then there was a couple of requests for you to comment again on the Innodb buffer pool instances setting, particularly on how it pertains to the number of CPUs in memory on the server.
Okay, yes. So about the Innodb buffer pool instances. So this variable helps us to relieve contention going from one pool, right, to serial one. And there are indeed many complicated angles apply to that. Right. First of all, if you are allocating very little memory to a buffer pool, then if you don't want to have it spread over many instances. My rule of thumb would be to ensure there is at least 1 gigabyte of buffer pool space for each of buffer pool instances. Well, thankfully, this setting is only important for large amount of CPU cores, right? And few of us will have 64-core server with only a couple of gigabytes of memory, right? That just doesn't make sense. Now, the second thing you have to consider here is what the larger values are not always better. Because a lot of things, a lot of algorithms inside of MySQL have to go buffer pool by buffer pool to perform certain activities. So they may be slower if you have very large number of pools. So, and there is also a lot more balancing things which have to happen. So be careful, don't just go ballistic and set it to very high values. And the third important dimension is what you want. If you're running Percona server, often you will be quite good even with the lower settings, because Percona server uses other techniques in addition to what the MySQL uses to alleviate their bottleneck on the utilities. Right? And I would say if you have some the number of 8, maybe 16 would be good enough up to 64 cores for most of our workloads.
Okay, so that brings us to the top of the hour. I have several questions about getting the slides to your presentation and the recording. Those will be available to all of you within the next 24 hours. There'll be a follow-up email that I'll send to you, and then they'll also be available online. So with that said, Peter, I will send you the list of all these great questions and look forward to a follow-up post from him in the near future. With that said, I'd like to thank you, Peter, and audience for participating in today's presentation. We hope to see you in the next one, which is next week, and it's on Big Data, Hadoop, and MySQL. Thank you very much, and have a good day, evening, or morning, depending on where you're from.
Thank you, everyone.